Welcome to Study Loop.
First, we will take part A, in which 3 kg of ice melts into water at 273 Kelvin. The heat needed to change ice into water can be calculated by the relation Q equal to mass times latent heat of fusion. Here, mass of water is 3 kg and latent heat of fusion of water is 33.5 times 10 to the power 4 joule per kilogram. This gives us Q equal to 100.5 times 10 to the power 4 joule. Now the change in entropy when ice melts into water can be calculated by the relation delta S equal to Q upon T. Here Q is heat needed to change ice into water, that is plus 100.5 times 10 to the power 4. Here we will take Q positive. This shows that heat is absorbed by ice upon temperature. Here is 273 Kelvin. This gives us change in entropy equal to 3.68 times 10 to the power 3 joule per Kelvin. So this is the answer of part A of this problem. Now in part B, 3 kg of water is converted into steam at 373 Kelvin. Again, we will calculate heat needed to convert water into ice, water into steam by the relation Q equal to m into latent heat of vaporization. Here mass of water is 3 kg into latent heat of vaporization of water is 22.6 times 10 to the power 5 joule per kg. This gives us Q equal to 67.8 times 10 to the power 5 joule. The change in entropy can be calculated delta S equal to Q upon T. Here Q is plus 67.8 times 10 to the power 5 joule upon temperature is 373 Kelvin. This gives us change in entropy equal to plus 1.82 times 10 to the power 4 joule per Kelvin. Now by comparing the two change in entropies in part A and part B, it is clear that the change in entropy in part B is more than the change in entropy in part A. As change in entropy is directly proportional to the disorderness, so we can say larger the change in entropy, more will be the disorderness. So in the process of vaporization, there is more disorder.